Scott Suzuki, you can call me voodooKobra, and this is a journey through the ecosystem of PHP frameworks. The battery's dead. Or maybe not. Okay, so a little bit about me. I'm a PHP developer. I'm not really into, I don't have experience with penetration testing and advanced exploitation and all the other really cool, sexy, fun stuff that you probably heard a lot about from everyone else's conference. My interest in security is that I believe that if you're a developer and you don't have any knowledge of security, you're irresponsible and you're a liability. I'm also a big proponent of open source. I run Linux on my laptop. I run Windows at home just so I can play video games with my friends, but every virtual machine that I use 90% of the time is Linux. All right. So what is a framework? Well, a framework is a library, usually standardized classes and stuff. It's meant to get applications off the ground really quickly without having to reinvent the wheel 100 times. Obviously, things like database abstraction, you probably only want to write that library once. Some software engineering patterns follow a thing called MVC, Model View Controller Separation, so that way you can have your database guy and your PHP guy and your web designer all working on different parts asynchronously without having to stop one thing and start the other, without them really stepping on each other's toes. Templating for the designer, and then you have routing for REST URLs. Those are the kind of things that a framework gives you. But is security one of them? So these are some frameworks I looked at through the course of this talk. Not all of them I'm going to find bugs in that I'm going to tell you about today, but these are just some of them. CodeIgniter, it's a really old one. Their development thing seems to emphasize backwards compatibility over security, and that's been a problem. Cake PHP, Laravel, I mean, if you ever if you ever program PHP and look for a job on Craigslist or whatever, you're going to see some of these show up, especially CodeIgniter, Laravel, Zend, and Symfony. So which one of these actually offer a security class? And that doesn't necessarily mean it's named security. It can be named security, it can be an encryption library, it can be a password hashing thing. Generally, these are the ones that give you some kind of security feature. Some of the other ones don't. Some of the other ones might have had one, but I couldn't find it when I was looking through the library to put together for this talk. So that's probably not comprehensive, but those are the ones that I was interested in. So these are the ones that I'm going to actually go into. So let's talk about some of the problems that you'll find in these libraries. The first one is weak randomization. I don't know if anybody's familiar, but there's several talks at Black Hat and papers out about black box testing of random number generators. And I believe with just 32 bytes of information, they can predict the next number with absolute certainty with things like RAND and MD-RAND. And you're going to see a lot of this in a lot of frameworks. Cake PHP, when you use their, I don't know how to pronounce that honestly. Reandeal, whatever, the AES guy, they use mcrypt rand as their flag for mcrypt create IV to generate initialization vectors for cipher blockchaining mode. Now, I don't know if you know the mcrypt flags, but you have 3 of them you can choose from. You have rand, which uses the rand function, which is not cryptographically secure. You have mcrypt dev random and mcrypt dev urandom, which use the dev random and dev urandom files on Linux, which are cryptographically secure. And this is what the actual code looks like, with the offending piece of code highlighted in red. Interestingly enough, it also uses mtrand in the UUID to generate authentication codes, or authentication keys. Yi is a different framework that also makes the same mistake. However, in a different part of the library, it actually uses dev urandom correctly, but when it comes to initialization vector, they fall back to random. And on Kohana, and I forgot to copy the source code into that, they have a weird exception that if you're running Windows, it only gives you the option to use rand. Internally with PHP, if you specify dev-urandom on Windows, I believe it goes to the crypto API and you get a secure random generator anyway, even though /dev/urandom doesn't exist on Windows. So doing this is just a really, really bad decision. Not that I really know anybody who runs PHP on Windows. All right, so poor cryptographic design. Generally, when you design a cryptographic library, you want to use the standards that have been tested and vetted by cryptographers. The reason for that is that cryptography is not hacking. Cryptography is mathematics and engineering. It can be fun to roll out your own code that does something really cool and share it, with your friends. But if you're going to put it in something people are supposed to use in production for their websites and for businesses, you're going to want to follow the standards that have been hammered on by the experts. So CakePHP's cipher uses a combination of srand with a constant seed and the rand function, and uses it like a stream cipher. It actually XORs the bytes with the plain text. There's another weird thing in CodeIgniter where they have a thing called XOR encode, which is extremely similar. There's also some other problems with CodeIgniter. Their getKey function, instead of a randomly generated key or anything like that, it just does an MD5 hash and outputs hexadecimal as a key, whereas you're going to want, a binary value. So that's really stupid. I reported that to it. They also have a weird thing called add cipher noise to try to stop against attacks like Beast and whatnot that attack the cipher blockchaining weaknesses. It's really sketchy. I haven't really analyzed if it will work or not, but just gut feeling tells me it wouldn't. And we addressed, me and a friend of mine in Canada and a couple other people addressed these problems on their GitHub, and they have a new library that's completely replacing this one in 3.0. The problem is they are dragging their feet on releasing 3.0. Go figure. And then Yi, once again, framework-based security manager. That's a typo, it should be capital S. By default, the class defaults to DES encryption, which, as anybody who's heard of EFF's deep crack back in the 90s will know that that's not adequate for anything. And once again, it falls back to a hex-encoded MD5 hash if you don't specify a key when you call it. Now here's the more interesting thing. This is a problem I can't just say is in a handful of frameworks. It's not necessarily a feature you might run into. It might not even be enabled. But there is a problem with poor session design in several frameworks. I found it in CodeIgniter and Kohana. I also found it in the leaked source code for PHPFox, which I don't know if that was legitimate, but somebody uploaded a PHPFox with modules to GitHub, and I looked at it and found that they did the same thing. So this is my understanding of what motivated them to do this, and I'll show you the mistake in a second. I believe they wanted to keep track of session state in a way that didn't involve the file system. So if you have like a multicast environment, or you have like a bunch of cloud servers, and something goes wrong with one, you switch the users to the other, you'd want to be able to not have to everybody log back in, or if temp gets wiped because of a reboot, if somebody was on 5 minutes ago, then they click, it doesn't log them out. Because by default, PHP stores session state in a temp folder. That's what I suspect the motivation was. The problem with that is, as you'll see in a second, it stores everything in a cookie. Now, two things are bad about that. One, cookies are limited to 4 kilobytes of data, so you're really cutting yourself off at the ankles if you need to do anything fancy. The other thing is that cookies are completely controlled by the user. You can change the cookies, you can send false cookies with every request, and they recognize that, so they decided they were going to authenticate it with a hash of the message being the default cookie or serialization of all the session data, and a key, usually stored in configuration. And they usually just append it together as the hash, which, from my understanding, leads to weird things like length extension attacks, but that's not the avenue I went. So let's take a look at CodeIgniters. This is the actual code to verify the MD5 hash of a session variable from the cookie. Now, does anybody see a bug here? Vulnerability. Want a hint? They're comparing it using the not equals equals feature, which, yeah, that might seem fine, but there's a weird quirk with comparison operators in C, PHP, probably every other programming language. And that's that it will start with the first byte and keep going until it finds one that doesn't match the two strings and immediately return. Now, that might not sound like a big deal. You know, that might actually sound like an optimization, something to be desired. But when you're doing cryptographic hash comparison, the sooner it fails, the sooner you know you know how far down the hash you got correct. And this leads to something called a remote timing attack. And how it works like this. You start at, let's say, 0, and you keep trying until you go through F, and you keep doing it, and you see which one takes longer to fail. And then you assume that was correct, and you keep moving down. And you know, you keep doing that until you have a hash together. And it looks something like this. You know, 0 all the way down fails immediately. But then D800 takes a little bit longer. And then this one's slightly slower to fail. And then you keep going, and you get your hash. And this is the thing you can do to the session state stored in a cookie with a hash appended at the end, with CodeIgniter, Kohana, PHP Fox, and probably a number of other systems. Now, if you're going to do a timing attack, you have to know one thing: it's very noisy. You're sending lots of requests in order to see which one takes longer. This is not something you can just, start Metasploit, run this payload, and have a shell immediately. On the other hand, compared to hash cracking, it's very fast. You don't need to know the key. You just have to know what message you want to send, and then play around with the values until you get one that works. It's like the movie, The Hollywood Stereotype of Steve Cracking, where you listen to see which one actually, oh, I heard the click, I heard the thing. That's essentially the same thing. If you know the first one's 23, you can start from 23 and try the next one, and keep doing that until you find it. And just on some back-of-the-envelope calculations, if you wanted to break an MD5 hash, Kohana, for reference, uses SHA-1, so it'll take 20% longer. If you only are able to send 10 samples a second, but you wanted 100 samples for each byte, or for each hexit, depending on, however you wanted to cut that, it would take you about 22 minutes of running this in order to brute force it. Now, that's 100 samples. You probably could get away with a lot less. It might take a lot more. It depends on the environment you're working in. So the takeaway, many frameworks offer security as a feature. People who actually use this to develop applications are going to depend on these features in their applications. And unfortunately, they're often very unreliable. For people who are actually framework developers, these problems are fixable. I've actually submitted pull requests to a lot of these problems. Not all of them, but they're coming. And finally, use the source loop. If you want to use a framework, check the source code, see if it does everything correctly. And that's all I have. Any questions? Yeah.
I have a question about the timing attack you just described.
Yeah.
Is it microseconds, the difference? I mean, when you're trying to, sort of figure out the actual hash, can you go a little bit more into depth with it?
Yeah, you might actually,
because it's just a string comparison, right?
Yeah.
The actual MD5, because the return has already happened from the MD5, right? So it's just the actual computation of the hash has already happened.
Yeah, this isn't an attack on the hash operation. This is an attack on the string comparison between the hash and the what is calculated from what you're passing it and what it expects it to pass.
Right.
And the other thing is that there's no actual failure when this happens. It just happens kind of transparently. It just destroys the cookie and says, hey, generate a new one. The timing difference is going to be, it's going to be microseconds. It's not going to be like a 10 millisecond difference for each character, because hash operations are extremely fast. That's why you need a lot of samples to actually detect it. But that depends on your environment. If you got two virtual machines next to each other, 100 might work. If you're an internet site somewhere out in like Russia, where you might have anywhere from 70 to 1,000 milliseconds latency, that's going to take a lot longer. There was actually a, I think it was it DEF CON or DerbyCon? There was a talk about remote timing attacks. I think it was last year. I don't have a reference to that on here, but Crap. If I had internet, I probably would have embedded a link to that. When I post these online, I'll reference that, so that way everybody can cross-reference that. Any other questions? There was originally a demo plan, but there was a lot of complications not having internet. Tried to hook up to my Raspberry Pi, and it was just not working. Yeah, I'm gonna have to work on that before I publish that. So, any other questions? Okay, well, this was a lot shorter than I intended it to be, but thank you for coming.